Welcome to another exciting installment of AP Computer Science. Make sure you have your notebook and writing utensils handy. Before we get to the tough stuff, I'm going to talk about relational operators, pseudocode, and algorithm. A relational operator is the binary operator that compares two values. The following symbols are used: the greater than, less than, greater than or equal to, less than or equal to, and finally, not equal to. The result of a relational expression is a Boolean value of either true or false. An algorithm is a solution to a problem. Algorithms will range from the easier, finding the average of two numbers, to the more difficult, visiting all the subdirectories on a hard disk, searching for a file. A major task of the implementation stage is the conversion of rough ideas into refined algorithms that can be coded in the implementation language of choice. Pseudocode refers to the rough draft outline of an answer written in everyday language, like divide by x or compare apples to pears. Once the pseudocode has been developed, translation into code occurs much smoother. Stepwise refinement is the process of gradually developing a more detailed description of an algorithm. Problem-solving in computer science involves overall development of the sections of the program, expanding each section with more detail, and later working out the individual steps of an algorithm using pseudocode, and finally writing a code solution. Alright, in the early modern days of programming, the approach to writing software was relatively primitive and ineffective. Much of the code is written with go-to statements that transferred program control to another line of code. This code consists of jumping from one spot to another, leaving behind a trail of lines similar to spaghetti. The term spaghetti code comes from trying to trace code linked together with go-to statements. The solution to this mess led to something called structured programming. The research of Baum and Jacobin has led to the rules of structured programming. Here are the 5 keystones of structured programming. 1. No go-to statements are to be used in writing code. 2. All programs can be written in the terms of 3 control structures: sequence, selection, and iteration. 3. Each control structure has one entrance point and one exit point. We'll sometimes allow for multiple exit points from a control structure using the break statement. 4. Control structures may be sequenced one after another. 5. Control structures can be nested inside another control structure. Using structured programming leads to a neater code and less work for you and others later. Going back to the keystones, there are only 3 necessary control structures needed to writing a program: sequence, selection, and iteration. Sequence refers to line-by-line execution. The program enters a sequence, does each step, and exits. This allows for sequences to do only a limited job during each execution. Iteration refers to looping. Java provides 3 loop structures: while, do-while, and for. These will be discussed in length later. Selection is the control structure that allows for choices. Java provides different levels of selection: one-way selection with an if structure, two-way selection with an if-else structure, and multiple selection with a switch structure. The general syntax of an if statement looks like if expression statement 1. So, if it's true it's sunny out, then bring sunglasses executed. If the expression is false, then nothing is executed and the program skips to the end of the curly braces. And here's a nifty diagram of it. The if-else statement looks like this: if expression statement 1, else statement 2. An example would be, if the expression "you are dead" is true, then "we're sorry" is executed. If the expression is false, then "pay taxes" statement is run. And here's a nifty diagram of the if-else statement. Oh, and a quick side note, the expression being tested must always be placed in parentheses. Now on to some fun stuff: nested if-else statements. Just like you can have nested parentheses in numbers in math, you can have nested code in programming. The statement inside an if or else option can be another if-else statement, or if statement. Placing an if statement instead of another is known as nested if constructions. Because Java is looking for one thing after the conditional, and that thing can be a single line of code or a block of code, your braces will need to be correct to ensure that the if and else's get paired with their partners. Indentation is ignored by the compiler, hence it will pair the else statement with the inner if. If you want the else to get paired with another outer if, as the indentation indicates, you'll need to add braces. An alternative to the previous example uses the double ampersand operator. A pair of nested if statements can be coded as a single line compound and statement. Both of these blocks of code have the exact same effect, but the second one is easier to read. Not too many seconds ago, I introduced you to the logical operator, the AND. There are three logical operators: AND, OR, and NOT. These logical operators allow us to combine different conditions. For example, if a dog is gray and weighs less than 15 pounds, it's the perfect lap dog. The AND operator requires both operands, also known as values, to be true for the result to be true. The following are examples of using the AND operator. The AND operator performs short-circuit evaluation. If the first operand in this AND statement is false, the operand immediately returns false without evaluating the second half. The OR operator requires only one operand to be true for the result to be true. The OR also performs short-circuit evaluation in Java. If the first half of an OR statement is true, the operator immediately returns true without evaluating the second half. The exclamation point operator is a unary operator that changes a Boolean value into its opposite. Java provides an alternate method to coding an if-else statement using the conditional operator. This operator is the only trinary operator in Java, as it requires three operands. The general syntax is condition, question mark, statement 1, colon, statement 2, semicolon. If condition is true, statement 1 is executed. If the condition is false, statement 2 is executed. The execution of an if-else statement depends on the value of the Boolean expression. We can use Boolean variables to write code that is easier to read. For example, the Boolean variable done can be used to write code that reads more like English. Instead of if done equals true, system.out println we're done, we can write if done, system.out println we're done. Programmers often use Boolean variables to aid in program flow and readability. The second version is the more preferred way of using a Boolean variable in this situation, because it's less dangerous. If you make the mistake of only putting one equal sign instead of two, Java will not catch that and interprets the statement as an assignment. Some strange results will occur, and it can take a while to catch and fix the error. And finally, switch statements. Consider a simple user menu for a store simulation program. There should be options to buy certain items, check your total money spent, cancel items selected, exit, and finish and pay. We could take the input from this menu and do a complicated nested series of if-else statements, but that would quickly become bulky and difficult to read. However, there's an easy way to handle such data input from a switch statement. Depending on which command is chosen, the program will select one direction out of many. An easier to read diagram looks like this. The switch statement attempts to match an integer value of the expression with the one of the case values. If a match occurs, then all statements past the case value are executed until a break statement is encountered. The effect of a break statement causes program control to jump to the end of the switch statement. No other cases are executed. A very common error when coding a switch control structure is forgetting to include the break statements that terminate each case value.
If the break statement is forgotten, all the statements following the matching case value are executed. This is usually very, very bad. If it is possible that none of the case statements will be true, you can add a default statement at the end of the switch. This will only execute if none of the case statements happened. If all possibilities are covered in your case statements, the default statement is unnecessary. Note that the default statement can actually be placed anywhere. If you place the default statement at the beginning or middle of the switch, you'll probably want to end default case with a break. Otherwise, execution will continue with the case after the default. Suppose we wanted to count the number of occurrences of vowels and consonants in a stream of text. Note that multiple case values can lead to one set of statements. It is good programming practice to include a break statement at the end of each switch structure. If you need to go back and add another case statement at the end of a switch structure, break statement already terminates the previous case statement, and there is no chance you might forget to add a break statement. There are programming situations where a switch statement should not replace an if-else chain. If the value being compared must fit a range of values, if-else statement should be used. And finally, the switch statement cannot compare double values. That's all I have for you today. Now go out there and code.